Hi everyone, and welcome to this lecture. In the previous lecture, we built a function that returns a list that contains the antibodies of a given population and their respective affinities with the antigen. Here we're going to create a function that selects the n best antibodies. This number n will be defined by the user as a parameter of the function. Let's create a function. Select. We have two parameters, affinity, which is the affinity, and number AB, which is the number of antibodies to be selected. I create a variable called sorted, which will be sorted affinity. We are going to sort the affinity list. We will also create a variable called reverse, which will be sorted in a decreasing order. And finally, I'm going to create a variable bests. Bests is reverse number AB. By doing this, I'm going to select just the n number of antibodies defined by the user and return bests. Let's run this function. Let's define a population of 20 individuals. Let's create a variable called affin, which is the affinity of the antibodies of this specific population. And let's create a variable called cell. Here we are going to use the function select, the variable affin, and the number 3. Here we have a loop for I in cell, print I. Let's give a space here for I in affin, print I. Let's run the function. So here we can see the 3 best antibodies from this population. You can realize that the affinity ranges from 0 to 121. The higher the affinity, the best the antibody. So these are the best antibodies, the 3 best antibodies with 71, 67, and 67 affinity respectively. And here we have the whole list of affinities and antibodies. Now let's select the 5 best antibodies. The 5 best antibodies in this case have 70, 68, 67, 66, and 65 of affinity respectively. So this was the function that selects the n best antibodies from the population. In the next lecture, we'll use and build a function that clones these best antibodies to constitute the new population of the new iteration. So I see you in the next lecture.